Dear children, welcome to class 9th mathematics. That is new chapter, areas of parallelograms and triangles. Already know that the what is the properties of parallelograms and types of parallelograms, and already know that triangles and the types. So let us see in this chapter what is the areas of parallelograms and triangles. So let us see. First we are going to see these two figures. See, here it is. There are two figures. Looking, these two figures are same shape and same size. Already you know that. What are the definitions of congruent figures? Let us see once again. Let us see what is the definitions of congruent figures. Dear children, congruent figures. There are two figures. Let us see. Two figures. Here it is. There are two. Here it is. The two figures. If we call two figures are congruent, or called congruent if they have the same shape and same size. They have the same shape and same size. Very important. Congruent figures, if the two figures are called congruent if they have same shape and same size. So that is then the two figures are called congruent. If two figures that is x and y, let us take x and y are congruent. If you take a and b also are congruent. See the adjoining figure. This is the adjoining figure. So we can see this is we can take a and b. So see, are congruent. See the adjoining figure. Then using tracing the paper. So then using a tracing paper, you know that tracing paper, we can suppose we can superpose. Superpose means one figure is coincide with in another figure. That is superpose one figure over the another such that it will cover the other completely. It will cover the other completely. That is the congruent figure. So you can write these two figures. So if you cut these two figures and put on the another figure, it is a, so both the figures are superpose one another, and the other figure is completely fill the another figure. That is the congruent figure. So that is a that is a b. So you can write the figure. So if two figures a and b are congruent, they must have, very important is, if two figures a and b are congruent, they must have equal area. It is region, equal areas. Both have equal area. That is the main important reason. That is, if these two figures are said to be congruent, both have the same area, that is equal area. However, the converse of this is not true. This is not true. So If you ask me the area is equal, then the two figures are to be said to be congruent. That is not a proper way. That is not a true. So area is the if the two figures are congruent, then they must have equal area, but not equal areas. Two figures are have equal area, but not it is not a not to be a congruent. Let us see the converse of the congruent. Let us see, that is two figures having equal areas. Two figures having equal areas need not to be congruent. Very important. Two figures having equal areas is need not to be congruent. That is the main. So in the adjoining figure, let us see the in the adjoining figure. In the adjoining figure, the rectangle ABCD and MNPQ have equal areas. So let us see the what is the rectangle A, B, C, D, and what is another one is rectangle means all angles are equal to 90 degree. So that is M, N, P, Q. Let us see, the length is 8 centimeter and the breadth is 2 centimeter, and this one is 4 centimeter. See, very important, area of a rectangle already know that length into breadth, L into B. So L into B, that is 2 into 8 is equal to 16 centimeter square. So the area is 16 centimeter square. Let us see similarly, already you know that area of a square, this is all sides are equal. Square means all sides are equal. So both have rectangle. Both have rectangle because all the angles are equal to 90 degree. Here it is also all the angles are 90 degree. So area of the square is A into A, that is 4 into 4 is equal to 4 into 4 is 16 centimeter square. So both have the equal area but need not to be congruent. So both have these two figures are not to be congruent. Next, second one is, see, area of a figure is a number. Very important, area of a figure is a number in some unit. That is associated with the part of the plane, that is enclosed by the figure, by the figure with the following two properties. Very important. Once again, area of a figure is a number associated with the part of the plane enclosed by the figure with the following properties. Let us see. What is the figure? First one is, if A and B are two congruent figures. Let us consider A and B. There are two figures are there, and they have two already given. Both the figures are congruent. That is already know that if the two figures are said to be congruent, they have both have the equal area. Then area AR means area of angle A is equal to area of angle B. So because both are the congruent figure. This is first condition. And then second condition is, if a planar region, formed by a figure T is made up of two non-overlapping plane regions formed by figures P and Q. See, what is the figure? Here it is. There are two figures. The plane in the figures made up of two non-overlapping planar regions formed by figures P and Q. Then area of T. This is the area of T. Total area, that is T. See, this is T is total area. That is area of T. Area of T is equal to, see, this area of T is equal to sum of the area of P plus sum of the area of Q. Area of P plus area of Q. So this is very important second condition. See, very important. Area of T is equal to area of P plus area of Q. Next, let us see figures on the same base and the same parallels. Here it is. Look at the following figure. First one is, see, here it is. There are two figures A, B, C, D. This trapezium ABCD and the quadrilateral EFCD standing on the same base DC. Very important. Same base. Figures on the same base and between the same parallels. Very important. See, in the figure 11.4, first one, this is first one, trapezium ABCD. ABCD is trapezium and a parallelogram EFCD. So have the common side DC. We say that trapezium ABCD and parallelogram EFCD are on the same base DC. Very important. Same base DC. Similarly, in the figure 11.4, second one. So this is second one. So parallelogram, both have the parallelograms. That is PQRS parallelogram, MNRS parallelogram. So these two parallelograms standing on the same base SR. So see, parallelogram PQRS and MNRS are on the same base SR in the figure 11.4. Then third one, see, third one 11.4, triangle ABC. ABC is a triangle. BCD is another triangle. So both the triangles standing on the same base BC. So see, parallelogram, this is the fourth one, triangle ABC and triangle DBC are on the same base BC. This is the BC. And in the figure 11.4, last one, so ABCD is a what is parallelogram, and DPC is a triangle. So parallelogram and a triangle standing on the same base DC. So see, BC and so a parallelogram ABCD and triangle PDC are on the same base. Let us see. Look at the following figure. Here it is. Same as it is same. Here it is. So in the figure clearly trapezium ABCD. A, B, C, D is trapezium and E, F, C both have the parallelogram and trapezium both have the same parallels. So it is EFD are the same base DC, and addition to the above, after above, this is above, the vertices AB of a trapezium ABCD opposite to the DC, DC and the vertices E and F of parallelogram ABC EFCD opposite base DC lie on the same line AF. So parallel to DC. So both have the same parallels. Here it is, both have the same parallels. So both the figures, so in between the same parallels, two figures in between the same parallels. Let us see the definitions of the figures. So two figures are said to be on the same base. Two figures are said to be on the same base and in between the same parallels if they have common base. So both having the common base, very important. The two figures are to be same base and same parallels, both have common base, and the vertices opposite to the common base of the each figure, very important. Vertices are opposite to the same common of the base of the each figure lie on the line parallel to the base, very important. So that is the figures same base and in between the same parallels. Carefully observe the figures. This is not a same base and same parallel, so because it's both have the same base QR but not a same parallel, because this D is not on the line, that is P. So similarly, so both have the same base HG but not in the same parallels because they are different lines. Here it is, both the figures are same base but not standing on the same line. So they very important. You can easily find out the which of the following figures lie on the same base and between the same parallels, such that such a case write the common base and the two parallels.